All right, guys. So this is where we left off last time. Hopefully you studied these reactions. You basically need to know how anytime an acid reacts with any of these five, 5 different things, what the products are. So again, if an acid reacts with a metal, if an acid reacts with a metal oxide, if an acid reacts with a hydroxide, if an acid reacts with a metal hydrogen carbonate, or if an acid reacts with a metal carbonate. Okay, next. This is a review. This is from topic 3. If you recall from periodic trends or periodicity, you guys should know this already. Na is in group 1. Mg is in group 2. P is all the way on the other side in group 5. So basically, as you have these metal oxides, or any kind of oxides actually, as oxides form substances with water, they go from highly basic to amphoteric to acidic. I don't have an example for amphoteric here, but it would be something like something from group 4 reacting with water, or something from group like aluminum oxide. So oxides change from basic to amphoteric to acidic across a period. You also know about acid-base indicators. You guys used phenolphthalein when we did the NaOH and HCl titration, and it turned pink. So that is one example of an acid-base indicator. There are multiple ones. We'll probably, I'll post a video for you guys to watch on some other acid-base indicators, since we only got to use phenolphthalein. Also review, you guys are familiar with the pH scale. Remember that it goes from 0 to 14. Remember that 7 is neutral, like water. Anything below 7 is acidic. Anything over 7 is basic. Another word for basic is alkaline. And so magic number 14, that's as high as it goes. And that goes along with what we're going to talk about next, which is the ion product constant for water. So Kw is the ion product constant for water. Now, the value of that is 1.0 times 10 to the negative 14 molar squared, or molarity squared. This is actually given to you in the study guide, in the data booklet. But let me tell you how they get it. They take the concentration of the H plus ions and multiply it by the concentration of the OH minus ions. Also, remember, square brackets mean concentration. This is the acidic ion. This is the basic ion. Multiply them together. This is what we have here. 1.0 times 10 to the negative 7 molar for the concentration of H plus. 1.0 times 10 to the negative 7 molar for the concentration of OH minus. And the total is 1.0 times 10 to the negative 14 molar squared. Again, this is the value of Kw. You can use that when you're doing your calculations, which is where we're moving next. So here are all the formulas that you need to know. They're not very difficult to use. You're just plugging them in your calculator. I'll do a couple examples here in just a minute. If you want to know the pH of a substance and you are given the hydronium ion concentration, all you have to do is plug in your calculator negative log of that concentration. Now let's say you want to know the concentration of the hydronium ions. You don't know that, but you are given the pH. Then you just plug in your calculator 10 raised to the negative pH. And it's the same for pOH. So this is for acidic, right? pH, H is the acidic ion. There's also what's called pOH. OH is the basic ion. So same thing. If you want to know the pOH, you just take the negative log of the concentration of the OH minus ions, again, which would be given. Or if you know the pOH, but you want the concentration of the OH minus ions, then you just put in your calculator 10 raised to the negative pOH. Also, remember, magic number 14 here, pH plus pOH will equal 14. So that makes it kind of easy to get either the pH or the pOH if you have one or the other. This little diagram was really helpful, and it like basically puts everything into perspective and puts everything together, basically saying multiply these two, this is the value you get, add these two, this is the value you get, which is 14. So this is 1 times 10 to the negative 14. This is equal to 14. See the connections there. If you're going from pH to H plus concentration or vice versa, these are the formulas that I just showed you on the previous slide. And then down here, same thing for pOH and OH minus. Okay, so with that being said, let me do one example. Let's say that you are given a pH of 3.78, or you were doing some kind of lab and you put a pH probe and the pH probe said that the pH was 3.78. All right, and your job is going to be to find the concentration of H3O plus, find pOH, and find OH minus. So that's your job, to find all three of those things. How are you going to do that? You're just going to use those formulas. So remember, if you have the pH and you want the concentration of hydronium ions, you just go 10 raised to the negative pH, which is 3.78. That's going to give you the concentration of H3O plus. Okay, find the pOH. Okay, well, we know that if you put the pH and you add the pOH, you're supposed to get 14, right? You know pH, 3.78 plus pOH equals 14. Subtract 3.78 from both sides. You get pOH equals whatever that is. 14 minus 3.78 should give you the value there. Again, you know the pH plus pOH is going to equal 14. It's just algebra. Subtract 3.78 from both sides. You get pOH equals whatever 14 minus 3.78 is. Okay? And for the last one, find OH minus. Well, that's easy because now I have pOH. So let's calculate pOH real quick. Let's see. So 14 minus 3.78 equals, okay, so this right here is 10.22, right? So I'm going to find the pOH by going, I'm going to find the concentration of OH minus by going concentration of OH minus equals 10 raised to the negative pOH. Yeah. So 10 raised to the negative 10.22. And that's going to give you the concentration of OH minus, whatever that is. Okay? So that's how you do those. And that's it. You're given you can be given any one of these values, any of these 4 values, and you can find the other 3 using these equations. What else? In the end, you have to explain, so is this an acidic solution or a basic solution? Well, based on the pH that is below 7, I would say that this whole thing is definitely acidic. There you go.